go ahead and talk about ramp or inclined plane problems, which are a very popular one in any physics course. Cool. So again, our first step, anytime we're solving a problem, first read it yourself, and then draw a good old free body diagram. So I'm going to go ahead and look at this block. So I'm going to draw my free body diagram. So I have the normal force, there's a surface pushing up on that block, and then we have force of gravity pointing downwards. Cool. And it says the surface is frictionless. Cool. So for A, we're going to want to find the acceleration of the block down the ramp. Okay, so now we're looking at the block is going to accelerate down the ramp in this direction. So normally we say like this is our y direction and this is our x direction. But in this case, the block is just accelerating down like in kind of both directions, what normally is x and y. So we're going to have to make a full new coordinate system. So we're going to say this is the x direction, and we'll say this is the y direction. Cool. So let's look at this to see what forces are just x, just y, both directions. So Fn, that is pointing just in the y direction, that's parallel to y. Fg is pointing not just in the y direction, not just x direction, but both directions. So we're going to have to split Fg, which we know is 100 newtons. We're going to have to split that into our x and y components. So if we did some fun old angle stuff, let's see, we know if this is 30, this is 90, this would have to be what, 60 degrees? We're going to split Fg into its x and y components. Okay, so this right here is going to be Fgy because it's your force of gravity in the y direction. This right here is going to be our Fgx because it's our force of gravity in the x direction. So we know Fgy is going to be perpendicular to the x-plane. So we know that has to be 90 degrees. So this angle right here has to be 30 degrees. Cool. So, okay, let's look at it. So now let's go ahead and use our handy dandy trig and find Fgx and Fgy. So we know Fgx, that's opposite over hypotenuse. So we're going to have to use sine. So that's going to be 100 sine of 30 degrees, which is 50 newtons. Fgy, that's going to be adjacent and a hypotenuse. So that is going to be 87 newtons. Perfect. Cool. So now, before we start solving, I'm going to go ahead and draw in a different color. Whenever we think about the problem itself, we're going to think about it in terms of just the components. So we have Fn, we have Fgy, and we have Fgx. So this free body diagram right here, which I'm going to highlight in yellow, this is the free body diagram we use for our thinking purposes only. Awesome. So while this one right here, if we're just drawing a free body diagram, it could be like a graded one or like a problem asked for just a free body diagram, only the ones left in black. That is just what I want you to draw, like if it's just asking for the free body diagram itself. Cool. So now let's go ahead and do some final math. So we want to find the acceleration of the block down the ramp. So it's accelerating in the good old x direction. So let's go ahead and set up F net x. So we know F net x is equal to the sum of the forces acting on it in the x direction. In this case, on this diagram right here, the only force acting in the x direction is Fgx. So we know F net again is always ma. Fgx, we got a number for that. That was just 50. The mass of this object is what, 10? So 10a equals 50. And then acceleration is just going to be 5 meters per second squared. Cool. And let's think about it. Does that make sense? So, okay, it's accelerating down a ramp. So is it going to be faster or slower acceleration than if something were in free fall? It would definitely be slower. So since it's slower, then the number has to be somewhere between 0 and 10 meters per second squared. And so that totally fits in terms of size. That totally fits in that kind of general sphere, whatever that word is, general sphere. Cool. So let's go ahead and do B. So let's find the force exerted on the block by the ramp. So the force exerted on the block by the ramp, that is our normal force. So let's go ahead and set up the y direction. So F net y is equal to the forces acting on an object in the y direction. So in the y direction, according to our free body diagram, we have Fn and we have Fgy. So Fn is going up, which we said was the positive direction. Fgy was going down, which we said the negative direction. So we have Fn minus Fgy. So let's go ahead and start to plug in some numbers. We want to find Fn. We found that Fgy is 87. Now let's plug in. So our mass we have is 10, and then acceleration we need to figure out. So in the y direction, let's think about what's happening. So it's tempting to want to plug in this acceleration 5 meters per second squared from the x direction. But that is the x acceleration, not the y acceleration. So in the y direction, we know the acceleration is just, it's not moving up and down. So we know that has to be 0. So we have mass times 0 equals Fn minus 87. So 0 equals Fn minus 87. And then Fn is going to be 87 newtons. So the surface is going to push up with 87 newtons of force. So let's go ahead and look at the last one. So we want to find the speed of the block when it reaches the bottom of the ramp. Assume the block starts from rest and the block traveled 2 meters down the ramp. So let's look at this. Anytime we know that the acceleration is constant, which it is in this case, it's just a handy dandy 5 meters per second squared. We can set up our VI, VF, A, delta x, delta t. The good old constant acceleration equations are always so fun. So go ahead and fill out your givens and then check back in. Okay, so we know the block starts from rest, so VI is 0. Acceleration, we just found that to be 5 meters per second squared. Displacement is 2 meters. We want to find the speed of the block when it reaches the bottom of the ramp, or VF. Cool. So now let's go ahead and do some fun old solving. So we have, so what is it going to be? VF squared equals VI squared plus 2A delta x. So we have 0 squared plus 2, A is 5, delta x is 2. So this is going to be 20. And then VF squared is 20. So VF is going to be what? Square root of 20, which is about 4.47 meters per second. And that is our good old answer for C. Awesome. Thanks for watching.